In this video, we're going to be checking out an RL circuit, and we're going to be finding the current immediately after the switch is closed. We're going to find an I naught through our inductor, and then we're going to find the current 3 seconds after the switch has been opened. And we're going to first take a look at what happens when we close our switch. When we close our switch, obviously now we are completing our loop, and what's going to happen is our inductor initially is going to be very resistant to any flow of current, and we're basically just going to have a flow of current through this little loop over here. And once we do that and have this initial flow of current, we can use Ohm's law and take a total voltage of 10 and divide it by the total resistance of 5 ohms because of the 3 and 2 combined in series. And then we get 2 amps for our first answer. Now that's the first thing that initially happens. Now, as time passes by, the resistance of the inductor slowly decreases until it basically becomes nothing and becomes a short. So the second thing that happens is the current will flow. It'll break up into this first and second branch, and then both of them will flow back around and complete the circuit. In this case, what's going on is now it's a basic parallel circuit as opposed to a basic series circuit with a 3 and 1 ohm resistor in each of the branches. So what we can do is find the total resistance by adding up the inverses. So 1 over 3 plus 1 over 1 equals 1 over RT. 1 over 3 plus 3 over 3, which equals 4 over 3. And then we want the inverse of that, which is 3/4. Now that's the total resistance of the 3 and 1 ohm resistor wired in parallel. But don't forget that any charges that are going through each of those branches also finish off by going through that 2 ohm resistor as well. So the voltage is going to be dropped one more time as they complete that loop. So for our actual final total resistance, we have to add that 2 to the 3/4, and then we get 2.75 ohms, or 2 3/4. So that's our actual total resistance with our parallel chunk and the green 2 ohm resistor included as well. Now, after that's been completed, we can now use Ohm's law once again and say that 10 volts over 2.75 ohms is going to give us our total current of 3.64 amps. Now, what we're interested in is not necessarily the total current that flows through the battery or through the circuit. We're more interested in the current that's flowing through our inductor over here in orange. So what we need to do is then analyze each branch individually. So what we're going to do then is focus on the branch over here with the 1 ohm resistor. So we know that the entire parallel chunk has a resistance of 3/4 in total. So if we take our I times that total R for the parallel chunk, then we get a voltage of 2.73 volts. And we know how parallel circuits work in the sense that if this has a delta V of 2.73 across this branch, then this branch also has a delta V of 2.73. Now that's going to help us get our current. So we know that the voltage across that branch is 2.73, and then divided by that 1 ohm of resistance from our purple resistor right over here, which comes out to a nice easy 2.73 amps. Okay, and that is going to be our I naught. All right, now we've completed most of the preliminary steps when the inductor had an extremely high resistance and everything flowed around according to these blue arrows. And then as that resistance decreased it and basically became a short, then we're going to follow these orange arrows, which helped us find our I naught. So let's go ahead and clear some of this space, and then we'll eventually get to our I3, which is our current flowing after 3 seconds once the switch has opened. Now for the final part of our problem, we want to use the formula I with respect to t equals I naught times e to the negative t over tau. And in order to find our time constant, we're going to go ahead and take our inductance and divide it by the resistance. So let's go ahead and see what that looks like. Now we're going to reopen our switch over here. And what that's going to do is cut off the complete path to this whole chunk that is on this side of the circuit. And it's basically going to leave this entire chunk over here. So let's go ahead and redraw this. So we want to find out what the current is after 3 seconds as soon as this switch is opened. And now the inductor is basically the main power source in pushing the charges around. Now, first, what we need to do is find the time constant. So we're going to find the time constant by taking the inductance of 2 divided by the resistance of 4. And it's 4 because of the 3 and 1 ohm resistor in series. And then that's going to give us 0.5. Now this number over here is going to be useful to us to slide into this exponent over here. And now we pretty much have everything we need. So now we're going to find I after 3 seconds has elapsed. Our I naught is 2.73 times e to the negative 3 for our time over tau, which is 0.5. So negative 3 over 0.5 would basically leave you with an exponent of negative 6. And then our final current is pretty small. It is approaching 0.007 amps for our final answer. So I hope that was helpful in helping you break down an RL circuit and find 3 different currents using several different formulas. Thank you very much for watching and listening.